For 400 years, the rivers of Scotland ran straight, not naturally straight, deliberately straightened, dredged, channeled, banked with earth and stone, forced into lines that moved water away from farmland as fast as possible. 4 centuries of engineering, 4 centuries of control. And then, in 2009, 5 beavers arrived in Knapdale, Argyll, and within 18 months, those rivers started doing something no human crew had been commissioned to do. They started bending. I'm Tom Marsh, and this is the story of how a rodent the size of a small dog quietly dismantled 400 years of drainage management and rebuilt a Scottish watershed from the bottom up, and why the people who should have seen it coming were still the ones most surprised when it happened. The first thing to understand is what beavers actually are. Not in the sentimental sense. In the engineering sense, a beaver is, by mass and metabolic investment, the most consequential construction worker on the planet at its scale. It doesn't just live in a landscape, it edits one. Dams, channels, lodges, food caches, scent mounds, everything a beaver does reshapes the hydrology of the ground it occupies. And in Scotland, that ground had been waiting in a very specific way for exactly that kind of reshaping. Because Scotland wasn't always the open, rain-washed, treeless moorland that most people picture when they imagine the Highlands. The historical record, and more precisely the subfossil record bones, gnawed wood, dam remnants preserved in peat, tells a different story. Beavers were once distributed across most of Britain. Place names encoded their presence. The Welsh word for beaver, afon, survived in dozens of river names long after the animal itself vanished. In Scotland, the river beverage, a handful of lochs whose old Gaelic names reference the animal, the landscape kept the memory after the beaver stopped, keeping it in person. They were hunted to extinction in Britain somewhere around the 16th century, possibly as late as the early 1600s. Fur, meat, and castoreum, a secretion from scent glands that medieval medicine considered nearly universal in its applications, made them valuable enough to pursue to the last individual. By the time the last Scottish beaver was killed, nobody wrote it down as a loss. It was simply a harvest that had finished. And then the rivers ran straight for 400 years. Here is what that actually means for a watershed. When you remove the animal that builds dams, you remove the dams. When you remove the dams, you remove the slow water. When you remove the slow water, you lose the wetlands, the reed beds, the bog habitats, the seasonally flooded meadows that held water like a sponge during heavy rain and released it slowly during dry periods. In their place, you get a landscape that shunts water. Fast out, fast in, the land stops buffering and starts funneling. In Scotland's case, that process was then accelerated by centuries of deliberate drainage improvement. Agricultural productivity depended on dry fields. Wet fields were a problem to be solved. And so the rivers were moved, the ditches were dug, and the peatlands that had once held hundreds of years of stored water were opened up and drained. Scotland lost the vast majority of its lowland wetland habitat over the course of the 18th and 19th centuries. Not through negligence, through intention. By the time conservationists began seriously discussing the return of the beaver in the late 20th century, the ecological argument was not primarily about the beaver itself. It was about what the beaver builds. The beaver was a mechanism, a delivery system for a suite of habitat functions that no government program, no engineered wetland restoration project, no amount of heavy machinery had managed to fully replicate. Because replicating it requires constant adaptive, localized decision-making. It requires something that responds to the specific gradient of a specific stream on a specific hillside and makes 10,000 small adjustments over the course of a decade. It requires the animal. The formal reintroduction began in 2009 at Loch Coyle Bar in Knapdale, Argyll, under the Scottish Beaver Trial, a joint project involving the Scottish Wildlife Trust, the Royal Zoological Society of Scotland, and the Wildlife Trust for Lancashire, Manchester and North Merseyside, with licensing from Scottish Natural Heritage. 11 beavers were brought from Norway, where a related subspecies of Eurasian beaver, castor fiber, had been carefully managed through its own recovery from near extinction. They were health screened, individually tagged, and released at monitored sites. The trial was designed to run 5 years. Scientists would track the beavers, record what they built, document the ecological responses, and then, in theory, the data would inform a decision. What the data showed was not subtle. Within the first 2 years, the beavers had constructed multiple dams across the trial site. Those dams raised local water tables. The raised water tables created wetland conditions in areas that had been dry for, in some cases, well over a century. Invertebrate populations in the affected streams began to shift. Species associated with slow, shallow, vegetated water beetles, caddisflies, certain species of dragonflies started appearing at monitoring points where they hadn't been recorded before. The dams trapped sediment. Silt that would have washed downstream and contributed to flooding in lower valleys was being intercepted and held. And the stream channels themselves, freed from the pressure of constant fast flow, began to develop the sinuous branching structure characteristic of naturally functioning watercourses. None of this was surprising to the scientists who had studied beaver reintroductions in continental Europe, where the animal had been returning across its former range since the early 20th century. What was somewhat unexpected, or at least what registered as more dramatic than the models had suggested, was the speed. A study published in the journal PLOS One, analyzing data from the Knapdale trial, documented statistically significant increases in aquatic plant diversity within beaver-modified sites compared to control sites in as little as 3 years. 3 years. Against a 400-year absence, the landscape had not forgotten what to do with slow water. It had just been waiting for something to slow it down. But Knapdale was only part of the story, and here is where the story gets complicated. While the licensed, monitored trial was proceeding in Argyll, something else had been happening on the River Tay. Beavers almost certainly escaped or released animals. The precise origin, never officially confirmed, had been establishing themselves along the Tay catchment since at least the early 2000s. By the time authorities began paying close attention, there were dozens of them. By the early 2010s, estimates suggested over 100 animals spread across a significant stretch of the river system, including its tributaries. These were not trial animals. They were not monitored, they were not sanctioned. They were simply there, doing what beavers do on one of Scotland's most significant river systems, on land that included active agricultural holdings, salmon fishing beats of considerable economic value, and a complex patchwork of landowner interests. And they were building. The response was not uniformly positive. Some farmers reported damage to drainage infrastructure. There were incidents of trees felled that landowners hadn't anticipated or wanted. The question of beaver impacts on Atlantic salmon migration, already a species under serious pressure, prompted genuine concern among fishing communities. The Scottish government's position was, for several years, awkward. Officially, the Tay beavers were unlicensed. Unofficially, removing over 100 animals from an established population would have been both logistically formidable and ecologically indefensible. The debate that followed lasted nearly a decade and involved farmers, fishing interests, conservation bodies, and eventually the Scottish Parliament. It was contentious, often heated, and it was real. This is worth saying clearly. The return of a functionally powerful species to a landscape that has organized itself around that species' absence creates friction. The romanticism of rewilding and the reality of rewilding are not always the same conversation. In 2019, the Scottish government announced that beavers would be given legal protection under Scottish law, making Scotland the first part of Britain to afford the species' native legal status. The decision came with a management framework, including provisions for farmers to apply for licenses to control beaver activity in specific circumstances, but the core decision was unambiguous. Beavers belonged. They were staying. By 2020, Population estimates for Scotland suggested somewhere in the range of 400 to 500 animals, concentrated primarily in Tayside, but with the Knapdale population also established. Subsequent surveys have shown continued expansion. And the rivers? A long-term monitoring study tracking hydrological changes in beaver-occupied catchments and Tayside research conducted by a team from the University of Exeter, published in the journal Science of the Total Environment, found that beaver dams were measurably reducing peak flood flows downstream of occupied sites during storm events, not eliminating flooding. Reducing peak flow, spreading the same volume of water over a longer period, which is, from the perspective of flood management, exactly what you want. To put that in practical terms, the Scottish government has spent hundreds of millions of pounds over the past 2 decades on engineered flood defense schemes for communities along Scottish river systems. The beaver, working without a salary, without machinery, and without a planning application, was providing a component of that same service as a byproduct of building its home. There is a figure that tends to land hard when people hear it for the first time. Research examining the economic value of beaver-provided ecosystem services, including flood attenuation, water purification through sediment capture, and carbon sequestration in the wetland soils that form behind beaver dams, has produced estimates in the hundreds of pounds per hectare per year for well-established beaver territories. The numbers vary by study and by methodology, and I want to be careful not to present any single figure as definitive because the science here is still developing, but the direction of every analysis points the same way. The animal pays for itself, and then some. What the models hadn't fully captured, what the scientists who designed the Knapdale trial were honest enough to say surprised them, was the cascading effect on species they hadn't specifically targeted. Otters. Brown trout populations in some of the slower, deeper pools created by beaver dams showed increases at sites where the species had been struggling under the pressures of fine sediment loading from agricultural runoff. The deeper, slower water provided refuge. Water voles, a species in serious decline across Britain, began using the margins of beaver-created wetlands at Knapdale, the kind of dense, wet, tangled vegetation that water voles need and that 4 centuries of drainage management had systematically removed. Kingfishers. Breeding waders returning to boggy ground that hadn't been boggy ground within living memory. The beaver didn't set out to help any of these species. He set out to build a dam, but the dam created a pond, and the pond created a reed margin, and the reed margin created a habitat, and the habitat created a food source, and the food source created an opportunity, and the opportunity was taken by animals that had simply been waiting in reduced numbers in degraded habitat at the edges of a landscape that no longer quite worked for them for something to change. This is the mechanism that rewilding science keeps returning to, not the individual species, the function. The thing the species does that no management plan can fully replicate, because management plans are written by people who have to predict in advance what a system needs, and ecosystems do not cooperate with advanced planning. They respond to conditions, and the conditions were set by a rodent that arrived in 2009 and started chewing. There is a word I want to leave you with: Loch Loskin, a small water body near Dunoon in Argyll, not far from the Knapdale trial site. The name preserves an old Gaelic element times loch, times, meaning lake, loskin, times a possible reference to a flat-tailed creature. The translation is debated by etymologists, and I hold it loosely. But the possibility that the word survived in that landscape for 400 years, embedded in a place name on a map, a reference to an animal that was gone before anyone now living was born, and that the landscape those words describe now, again, contains the thing they may once have named. That is not something I can improve on with a metaphor. What happened in Scotland was not a recovery in the simple sense, it was a reactivation. The watershed didn't need to be taught how to hold water. The species didn't need to be trained to build dams The invertebrates didn't need to be informed that slow water was available. The system had a shape it wanted to return to, a function it was capable of performing, and it had been held away from that function for 400 years by the absence of one animal. We put the animal back. We argued about it loudly for years in Parliament and in farm kitchens and at fishing association meetings. We put legal frameworks around it and management provisions in place and monitoring programs that are still running. And then, imperfectly and contentiously and with real costs to real people that shouldn't be minimized, the river started bending again. Not because we restored the landscape, because we returned the animal that knew how to, and eventually, mostly, step back. That's what I believe this story is really about. Not the beaver specifically, the principle that the knowledge of how a place should work is often already embedded in the species that shaped it, and that the most powerful thing we can do is sometimes the hardest: get out of the way. I want to know what you think. If you had the choice, a species that was native to where you live, gone for centuries, ecologically important but practically disruptive, would you bring it back? Where is that line for you? Leave your answer in the comments. I read them, and the conversations down there are worth having. If this story made you think differently about what rivers are supposed to look like, share it with someone who might feel the same. And if you want more of this, the cases that didn't make the news, the recoveries that are still unfolding, the arguments that don't have clean endings, then subscribe. There are more stories like this than you'd imagine, and I have many more to tell you. I'm Tom Marsh. Thank you for watching.